Francois. So it's time to wrap up and discuss a little bit over the content of today's presentation. So I can invite all the speakers to the stage. So the roundtable will be moderated by Michele Pellizzari, who is a professor of economics at the University of Geneva. And I should mention now that Michele is, he was really the one behind the organization of this event. So, and so it is our credit for today. And so again, the purpose of the roundtable is to reflect a little bit generally on the many issues that were raised during the different presentations, and possibly try to draw some conclusions on what we can do to handle and analyze this data better. There should be chairs for everyone. Are there?
You stay there. Then I'll see.
Are we all?
No, here.
You are, Lynn.
No. We all set? So great. I mean, just to clarify what Marco just said, I didn't do anything for the organization of this workshop. We just discussed the idea of organizing something about the use of data from surveys like PISA and PIAAC in secondary analysis, because we had the feeling that there was a very interesting debate being present in different papers discussing these issues, but also we had the feeling that a lot of people were using these data without full 100% understanding of how the data are produced and how they should be used. And from my point of view, I think this has been a great success. I have a hard time recalling a workshop or a conference where I've learned so much as today. And while listening to the different presentations, I sort of wrote down a few bullet points in a couple of slides to sort of try and wrap things up. I thought, let's keep this very flexible. One idea that I had for a roundtable was to sort of organize it around the idea of coming up with suggestions, perhaps for the OECD, about what could be done to improve the usability of this data and hopefully the correct usability of this data. Oh, okay. So there's one button that says,
No.
Oh, this one, okay. So forget about the minutes. It's something I should have erased. It was more for me to organize things. But I thought there were 4 issues that perhaps would be useful to go back to. One is the scaling. 2 is perhaps the one that has received the most attention, which is how these proficiency scores are produced and whether and how they can be used as individual measures of individual proficiency. One issue that has not been discussed so much, but it's been touched upon by several presentations, I think it's pretty important, so I'd like to sort of pick your brains on this, is the role of the parametric distributional assumptions that are made in the measurement models. And then something about the weights. Jeff gave a very comprehensive presentation about the use of weights, but there's one specific issue about PISA and PIAAC, which is how you should use weights when you pull data from different countries together, which is I think something that several researchers do, and I thought it was a useful addition to the discussion about weights that we've had so far. But as I said, this is my own quick bullet points that I put down during the presentations. So let's keep this very flexible, and whatever you feel would be useful to share with the audience, and then we'll try to open the floor as well. Feel free to sort of add it. Okay. So, but if you agree with this sort of outline. So scaling was one of the issues that was discussed, and I was sort of thinking whether it seems important if we want to attach some meaningful interpretation to the parameters that are estimated using this data. I was wondering whether the OECD could actually take the lead in some sense at offering some kind of scaling that could help researchers using the same data interpret parameters in a similar way. Maybe yes, maybe not. According to the views that I've been able to sort of collect during the different talks, I guess Andrew in some sense proposed some very natural scale that seems to be more internal than external according to the terminology that Jesse used in his presentation. So that might be a starting point, for example. But then if I've interpreted correctly what Edwin and team have said, they would probably both disagree on the simple fact that there exists a common scale that can be good for all the research questions. So I don't know. Let's perhaps start here. I don't know. Tim, would you like to?
Yeah, sure. I mean, I like the idea. I mean, I like the spirit of it. I think in sort of thinking about this, I've been thinking about some things in a different context lately that are really related. Where we were trying to measure happiness, and maybe you can sort of base that on brainwaves, even though we know nobody actually cares about the intensity of brainwaves. It's at least something to map things to. You can sort of think like, I don't know the metric system either, but I think is it grams? Is that metric? Yeah, and it's based on like some rock in a basement somewhere in Paris, and nobody cares what that rock actually is, but at least it gives us something to tie to, and everybody seems to accept that. I think I guess I'm concerned about why we couldn't do something similar with test scores. At least the way that things are organized now is that when we talk about the extent that you could impose and say that test scores are interval, it's always on an internal scale to that particular test. And I think that policy makers and researchers are going to have difficulty having many different tests that are ostensibly trying to measure the same thing. Though of course every test is going to be measuring something slightly different way, but you can't compare across tests on that scale. And so trying to tie some sort of universal internal scale I find difficult as a way forward, though I'm open to ideas on it. I think, again, if we go to an external scale, I love that idea, but choosing which one, and as I sort of said during the talk, I think it matters what the context is. I think what you really need to go in that direction would be policymakers to come to an agreement about what we're trying to use these tests to measure. What is it that if we're trying to measure tests to see, like, for example, how good our schools are performing, what's the end goal of the schooling system? And that's a whole can of worms. I mean, again, be interesting to talk about it, but I think it would be difficult. But I like the idea.
Any view from the floor, perhaps Edwin or Andrew, on this, or someone from the OECD? Do you see this as something which could be done, would be useful for your work as policy advisors?
I have strong opinions, but I'll defer to OECD and the panel.
William.
I mean, it's not just, it's just to remind people that there is a described scale, and that's detailed in the reports and in the technical report, and that really one of the objectives in the scaling process is to describe the scale in terms of the properties of the items that are measuring the construct that's intended to be measured. And I think I just worry a bit in this debate that we actually lose sight of the fact that the measures are designed to measure a construct which is defined in a particular way with particular dimensions, and it's not just something that you can play around with in one sense. And I'm sure Matthias has something to add there, but just to say the whole process of developing proficiency levels is a way of, in a sense, anchoring or describing what we are measuring, even if sometimes it's a bit difficult to interpret what it means to have 10 points more than someone else. You have an idea of the progression of proficiency as you move up the scale.
Matthias, I think you wanted to.
Yeah, sure. Yeah, one issue is also related to the fact that we are not just measuring one thing, but many different things. Among other things, PISA spends a lot of effort and money to produce a innovative assessment with an innovative construct every 3 years. There are altogether a few optional scales. You probably have to correct me about that. There's financial literacy, there's now this innovative scale, there's mathematics, reading, literacy, science. So those are different subject domains. There's not just one scale that you can somehow anchor to some external thing that gives you a universal interpretation. That is one thing. I think the other part to remember is that even if you can transform one thing to another, there are still different meanings. I think one of my colleagues once made the case that your blood cholesterol and your age are highly correlated, but they are really different things. The same is with cognitive decline. So once you get older, things don't function that well anymore, but you can't really just equate cognitive decline with age completely. You can't equate cholesterol levels with age completely. So you really have to take care of this kind of difference between different things that you're trying to measure. And I think maybe just going back to William's point is that these described scales that will also give you some reason behind why things might work differently at different points of the scale, why different problem areas can be solved by people very high on the scale, and adding 10 points doesn't change it that much, whereas having the same kind of increase at the lower end of the scale might really produce a completely different outcome in terms of whatever you might say, whether it's finishing school or something else.
So I'm going to be a little bit more Tim than Tim on this question. And I want to say that I don't think it makes any sense to kind of be top down and say, here is the right scale for this. I would much rather that we be agnostic and let users figure out what question they're trying to answer and try to adjust the scale to fit what they're trying to do. To give an example, I'm a labor economist. One of the themes of labor economics over the last several years has been how technological change is affecting the labor market. And to vastly oversimplify a complicated literature, one of the results that has become popular is that in the early years of technological change and computerization, it was really replacing lower level cognitive skills. It was basically taking, instead of cashiers needing to add up the bill, now the computer would do it and you didn't need to know how to add. And then as computers have gotten more complex, they're replacing skills higher up in the distribution. Well, if you want to understand how the proficiency of the population relates to the needs of the labor market, that's going to depend a lot on where you are in that cycle. And so for some analyses, you might want to put a lot more weight on arithmetic ability, and on others, you might want to put more weight on algorithmic problem-solving ability. And I think it's very hard for the test maker to when they decide to design the test, to decide this is the one and only way in which we want to weight these different skills, and nobody else should be ever allowed to use this data for anything else. I actually think the way that we do it right now works pretty well on the scaling issue, that we use different scales for all the tests so nobody's under the illusion that they're all measuring the same thing. But then if you want to use the plausible values and you want to say, well, actually scores above this point mean more than scores below it, you can always rescale those plausible values, and that's okay. And that's actually one advantage of the plausible values approach, is that you can do that. And that seems to me to be a valuable thing, to allow researchers to decide what parts of the original construct are most important for the question they're after.
All right, Andrew, would you like to have a final word on this, or no? Okay. So, am I interpreting this correctly? That there seems to be agreement on the fact that it'll actually be detrimental to have a common scale, or sort of, an authority like the OECD proposing a scale that could be used by everybody. So there seems to be agreement on the fact that this is not a good idea. Good. So let me move on to sort of the second issue that I think is super important, and I've learned so much today about this. It's this idea that the IRT model, how we should be using the IRT models or the estimates of individual proficiency for secondary analysis. And I was thinking about, what solutions to this issue we might think about. And I've been thinking about 3, but there might be more. And in all cases, I felt like there was a consensus on the idea that plausible values are not particularly useful tools. I haven't sensed great enthusiasm about plausible values in any of the speakers. So one thing that has been coming up several times is this idea that, you may want to adjust the measurement model, the IRT model, for any type of secondary analysis you may want to run. So one possible thing that could be done is disclose more information about the functioning of the IRT model and allow researchers to adjust it to the need of their secondary analysis. And then this could be done in 1-step or 2-step approaches, as Irini has described. So this also points in the direction that plausible values that are based on one particular specification of the IRT model and one particular set of conditioning variables for the population model are not necessarily good for all secondary analysis. So another thing that I've been thinking of is a lot of these problems arise from the fact that we're using one tool for 2 rather different purposes. One is the estimation of the distribution of proficiency in the population or across population groups, and the imputation of individual proficiency scores. So how about we use 2 different tools for these 2 different things? I guess as economists, we might be willing to trade off less precision for a measurement error that may have a large variance, but that we know how to deal with. So think about a super simple measurement model where everybody answers the same smaller set of questions, and then we average or we sum the number of correct answers over those 5 or 10 questions in literacy and numeracy. And then perhaps the test is then adaptive on other dimensions, and there's people answer more questions perhaps in an adaptive way, but then there's this core set of 5, 10 questions on literacy and numeracy that everybody answers. Of course, the literacy and numeracy measured according to this very simplified model is going to have less precision, it's going to be more mismeasured, but perhaps the statistical properties of the measurement error are going to be sort of properties that we know how to deal with. And the third possible solution that I've seen in several presentations is that the plausible values are biased estimates of the individual proficiency, but there are ways to produce unbiased proficiency scores. Here, this is possible conditional on the primary and secondary model being congenial to each other, and this has come up several times in both Jess's and Lean discussion. So I summarized brutally your very clear discussion about this congeniality in terms of the YXZ problem, which to me makes the kitchen sink approach inappropriate, because I think we all run secondary analysis with different Y variables. That's the killer to me. And as long as you have the Y variable in the conditioning set, then the bias is pretty large. But then you also showed that the bias is small for tests with lots of items. So perhaps this is not such a big problem in surveys like PISA and PIAAC, where the number of questions is pretty large. So I don't know. These are my, and perhaps we can, should we encourage the OECD in taking one particular direction, and instead of, or together with the plausible values, do something more or different along these lines or others? I don't know. Lean, would you like to take first go on this?
Do you want to start?
Nope.
Okay. So it seems like your answer 2 and answer 3 are in opposition to one another, right? Because answer 2 says a smaller set of tests, or I'm sorry, a smaller set of items, and answer 3 says, well, but actually we need a longer test, so we don't have this. I'm not convinced that a smaller set of items that everybody takes gets rid of the problem with the standard errors, right? Because the standard errors are still going to be different for everybody, even if everyone's taking the same set of items. So I don't think the fact that the standard errors are different are a result of the incomplete block design that exists, but more in the fact that, I mean, sort of a simple example I often use is I'm guessing that if I gave everybody in this room a first grade math test, it's not going to do a very good job of distinguishing among those of us who are pretty amazing mathematicians and those of us who are on average. Whereas if I gave us all, say, my colleagues' final exam and real analysis, that might do a better job of distinguishing. Or maybe that's too hard, and that's going to do not a good job as well. So I suppose that it's certainly possible to think of a simpler and less precise measurement model. But for me, I think the fact that those standard errors are still very different across different individuals, I'm not quite sure. I'm not smart enough to figure out how to handle that. So I defer to others of you who are smarter than I. I think that I agree with you on some level that my preference would be to simply just disclose more information about the IRT model and to find a way within 1,000 pages to both reduce the number of pages but also make it a little bit more clear. And I also don't know how to do that, so I also defer to all of you to think about how to do that. Some of that I think is up to those of us who are using the data. It behooves us to understand it in, I think, better ways, and those of us who teach these models to be doing a better job of teaching the next generation that they can't just place theta hat within a model there. So I'll let others talk.
Yeah, the limited enthusiasm about the plausible values, at least in my talk, that was just because I'm German. So, so otherwise I would have been very enthusiastic and said that this is really good for the stuff it was built for. I think we have to acknowledge that we are stretching the limits of what they were originally intended for. The disclosure about the IRT model, I completely agree with that, but I think all the organizations, despite the heavy workload, are working on that. So Peter just told me that he has been teaching for 6 years in those ERI academies. So we've been doing those academies from IEA, ETS collaborations for 10, 15 years maybe now. There are sampling workshops on what is taught by Sabine, and there are IRT workshops. There are a lot of resources online outside of those big organizations such as OECD and IEA. I had a presentation that we couldn't show in this time, but I'm happy to share it about IRT-based software. There are online resources. I think, again, those 1,000 pages are really frightening to read, of course, because you don't really want to go through all the information that you might not really need, but there's information out there. The data is really, maybe everything can be improved, so it can be better here documented, but essentially you have all the tools in hand to run IRT models on those data, and I know researchers who've done that. There are people who rescale this stuff. In the early rounds of PISA, for example, some countries that had a little bit more experience tried to rescale their data based on the concern that, and I try to get an intelligent segue to the second point. They try to rescale their results based on the minor-major domain distinction. I think especially Australia, Germany, and a few other countries, because they saw very different trends depending on whether they would look at the short test, and there's the segue, which would be the minor assessment, which consists only of 2 or 3 blocks, versus the major assessment that has 6 blocks. And the segue is the short test as a range of problems. There is so-called diff, what educational researchers call differential item functioning. So if you have short tests with limited numbers of items, you run into the problems that there might be differences across countries, how they are taught. In large collections of items that establish the construct across countries, you have countries providing input about the range of items that should be there, whether they're culturally appropriate. So you can't really just say, oh, but I like those 10 items and we're using those because they give a nice little assessment. There are differences across countries that would be not only exaggerated by that, but they would actually lead to comparisons that would shift depending on who has the say about what are those 10 items to be chosen. So there's a reason for why there are 300 items. Another reason is security. Once you would have only those 10 items, guess what would happen? So while it is low stakes for individuals, it's pretty high stakes for some countries. So they would try to get at those 10 items, and they would practice the hell out of them, and then every student in that country will have a perfect score on those 10 items, because they just know those responses. So you have to roll over the item bank. You have to provide trend measures, so you cannot run those items forever, so you have to change them, which makes it, again, the need for a much larger item set. Yeah, and then again, I think in the last case, certainly, I think you want to have an alternative to plausible values. Again, I should have been more enthusiastic. The stuff they were built for, they do pretty well, but you have the alternative running additional, more sophisticated models by going back to the item level data, using the weights, and yeah, following best practices. And again, the software market is really exploding, so there are many, many tools that you can be using.
Sorry, I had the impression during our panel, and I have it again now, that we were kind of violently agreeing. I agree. If the plausible values are the right thing for the thing they were designed for, and when we were doing this 15 years ago, that was probably the only option, because the computing power wasn't there for other alternatives. And we still ought to release them. I just think we ought to offer more as well. So a series of things one could offer. One could have these software packages that we just saw. I love the idea of not requiring every user to code up the replicate weights analysis, not requiring every user to code up the plausible values analysis. We could also not require every user to code up the IRT analysis. That even if the item responses are in the data and the IRT parameters are there, it's an enormous amount of work to code up the IRT function, and we could just distribute that as a function in R or in Stata that people could call that says, you give me a theta, I give you the probability of the observed item responses. That would feed directly into MECE or into the marginal maximum likelihood for the independent variable cases, and would be really helpful. We could also, in fact, distribute the MML and MECE packages. There's no reason why. I think there's pretty broad agreement that those are the right ways to do it if you had access to the item level data and had the sophistication to do them. There's no reason those need to require more sophistication to run than just type in regression, as long as the package is there. So I would support distributing packages to do things like that.
And that allow changing the set of conditioning variables.
Absolutely.
Any reaction, comment from the floor? All right. Oh, sorry.
Andrew has his hand up.
Andrew.
I just want to quickly emphasize, think of three things, right? Design, reporting, and then facilitation of secondary research. I don't think anyone's suggesting changing the design or reporting, so that might be like a no on the second thing you have up there, right? I think it's, to Jesse's point, really about facilitation of secondary research. I think, to Matthias's point, plausible values still have an audience and still represent a kind of transparency about where you got your reported scores and scale scores from, and I think they should stay. But I think now that you've got that programmed already, now's the time to invest in facilitation of secondary research in the way that Jesse describes.
Thank you. All right. So if there's no further comment, let me move on to another issue, which is the parametric assumptions that are imposed on the IRT model. There were some there was both Lynn and Sergio sort of touched upon this issue. I was wondering whether you could say more about how sensitive the proficiency score are to the choice of the distribution. Lynn sort of suggested it's not so important. Sergio showed that when you try to estimate these latent factors non-parametrically, they often seem to be distributed very differently from normal. And there are, I remember when I worked at the OECD for some time, there were discussions about some countries sort of claiming that the distribution of this proficiency score plausibly were more polarized rather than normal. So you have some countries where some groups of the population go to some elite education, and maybe the group is small, but it should show up somewhere in the distribution. So I have absolutely no idea what could be done, but I thought it'd be interesting to sort of talk a little bit more about it. Should we start with Sergio?
So I think you're bringing in a very important point and has deep consequences on how we approach this. So when it comes to testing for parametric assumptions, is something we can do. I mean, of course, it depends on the data we have access to, but in principle, the softwares, the techniques are out there. You can use them. But I think, more generally, I think the main concern, and it's connected again to what you said, is, who is the final consumer of the information you are providing? I think that's something, a discussion you as the OECD should sort of focus on. And see, if you think about it, I mean, there's a bridge between fields, people using, the same techniques, the same data, but at the end we have different words, and there's a bridge there there's a gap to bridge there. But when it comes to, policymakers and researchers, that's a huge gap out there, right? So when it comes to estimation, we're one click away of getting the parameters. I mean, I don't think that's the issue. I mean, the softwares are out there. I mean, and they're free and they're fast, and you have computers, and so I don't think that's a question. I think the issue is identification, understanding what you are actually getting from the data you are analyzing, and that's a massive challenge. And when it comes to the role of institutions such as the OECD in this context, I think, facilitating access, providing clean data and information is important, but educating people how to use this information, I think this is a major challenge, and that's something I have not seen happening. I mean, the World Bank is trying to do, they collect the data across countries, and they try to, be careful with the way they feature the information, but at the end of the day, the countries get the data, they do whatever they want, right? And the same thing happens with the PISA, and so educating. I think the real challenge here is, educating the final client. And researchers are going to be careful because we worry about our research being published, and we're going to have referees going through the papers and so on. But the guy at the Ministry of Finance in Argentina who's getting the data and is trying to produce a result to please the minister or someone. I mean, that's something you need to help, to inform people that this is the right way of doing it. I think that's something that should be part of the agenda, and unfortunately, it's really hard, but, it's something I'm missing, to be honest. And I think it would be a great contribution, not only to science, but, again, policy making for the OECD to help in the process.
So I'll be honest, I think I'm slightly less concerned about the parametric assumptions that are made within the various models, and I'm more concerned, and in some sense this covers, or this sort of touches on the issues of scaling as well as the various issues here, and the idea that, and I think this is what Tim sort of said, right, that we are in many ways, the tests were designed for a very particular purpose, and they're designed to measure a very particular thing, and yet secondary users, for lack of a better term, though I appreciate the idea of not separating primary and secondary users quite as specifically, are really trying to take these and use them as proxies for something else. And so I think it's in some sense, not just the aspect of the measurement models. It's not just the aspect of the calculus and probability, if you will, but it's really the ideas of what exactly are being measured. And I think that's a lot of what some of Tim's work and Sergio's work are both showing, right? That different proficiency scales or different measurements or different latent variables are in fact going to predict different things in different ways. And the assumptions that I think we are making about what we are using to proxy for various other things, so using, say, the AFQT to proxy for human capital, or using a proficiency score from 4th grade math to proxy for human capital in the workplace when someone is 30 years old, those might be larger assumptions that we have to really think about and worry about.
I have a naive question for the people who understand this. So when I was sitting watching both Sergio and Lynn's presentations, I couldn't quite tell when linear models were being used for discrete outcomes. So the theoretical models written down were linear, but then there were several discrete outcomes which were reported. So as I said in my presentation, I'm not one of these knee-jerk people who says, oh, now you're using a linear model for a binary outcome. But isn't all part of this scaling issue making sure that you're also careful about upper bound effects and so on? So if you're using this theta I as a right-hand side variable and you're so concerned about how it's being scaled, but now you're assuming it has a linear effect on a binary response, then I don't quite know how to think about that. So I'll stop there.
Can I? Yeah, no, you're absolutely right. I mean, the models do not impose, I mean, you know, when it comes to what I showed, those are nonlinear models. So you are not imposing linearity when it comes to the identification of the factors and the estimation of the factors. So if you have a binary outcome, it will be, you know, a binary model, not a linear regression model. And that, is it important? You know, it will depend on what you want to get, right? So when it comes to the sign of the parameters, maybe it's not that important, or the derivatives. Yeah. When it comes to the treatment effects, it's really important.
Yeah, so this is the campaign to save the plausible values here. So just to make clear, and I don't know whether that question also was directed to that, the normality assumption is tucked away in those conditioning or imputation models at the level of the residual, more or less. So what you get is essentially a mixture or multiple group model over probably millions of combinations of background variables. So what you really get is more or less a kernel smoothing among millions of teeny tiny normal distributions. So there's really no general assumption that anything on the macro level is normally distributed. So that might help a little bit. But otherwise, we also had some research looking at whether you could draw plausible values conditional on all these background variables and then still assume a kernel smoothing or whatever, something non-normal. And at that level, it simply doesn't make a difference because you're already conditioning on so many other variables that this is really just a residual error variance term that has, a little bit of variance, but the major portions are already explained by the many variables you're mixing over.
Yep. Go ahead.
I guess my only point was going to be also responding to Jeff in that in some sense, the number of items you have sort of determines how continuous your theta scale really even can be, right? So in the case of those TIPI scores that I have where I've got 2 items, right, what I really have are 4 possible options at the end of the day for every individual. So do I think that's a continuous variable? Probably not. And so you're absolutely right. And so again, in some sense, the longer the test, the more able we are to be able to say, yeah, maybe we can at least estimate that as being, or approximate that as being continuous. But for these very short tests, that's going to also be highly problematic.
Is it 2 items? And then
well, it's 2 items, and so...
they only have...
Oh, I guess they have 5 categories, so it's a little bit more than that. But on a binary scale, yeah, exactly. Thank you. Good point.
All right. Yep, please.
Distal outcomes, and then you make, assumptions. Those can be continuous outcomes, or could be binary, which is kind of more straightforward because you use logistic or probit regressions there. But the other thing is, I think it's also sometimes important when applied people have the actual data, because they can also test for outliers or response patterns that they've been created by other response strategies. So I think, it's very great that there are the plausible values and people can use them, for certain things, but it's also good if people have the data and they can experiment with the data and see, by doing sensitivity analysis and making different distributional assumptions, whether they get the same answers. And I mean, more recently, what I always advise my students is do a sensitivity analysis and see whether it makes a difference. So, you treat it as ordinal, you treat it as, continuous. Does it make any difference to your final results, for example? And if it doesn't, then, choose the simpler version. But so I think so we don't get into the same trap with regression analysis that we fit it and we never test of any assumptions, but we just get the output and carry on, interpreting it.
So I completely agree that we should always test our assumptions and we should always do sensitivity analyses. My only point in my earlier comment about saying I was less concerned about the parametric assumptions than some of the others, right? This is when I teach sort of our Stat 101 class, right? I talk a lot about biases and survey questions. And frankly, the biases that exist in those questions are going to be far greater, right? So if I ask a bunch of people a question like, have you had an abortion or not, right? I know that there's going to be a certain amount of bias in the fact that lots of people are going to say no, even if in fact they have. That bias, I'm guessing, is a whole lot larger than any bias that's going to exist in any kind of choice about a parametric model that I'm going to have about whether or not I include that question somewhere along the way within there. So my only point is just that I think what we're measuring is a very difficult question to answer, and we're using a lot of these variables as proxies for other latent variables, right? So we're using math proficiency in some cases as a latent variable for human capital. My sense of human capital, and I'm not an economist, is that that includes a lot more than how well I can answer a bunch of questions on a math test. And so my only point is just that I think we have to be very thoughtful about how we're using tests that were designed to measure specifically, say, math or reading comprehension or whatever, to model these other things that economists and some educators and some areas of psychology and others are actually trying to use those for.
All right, thank you very much. So let me throw a last question of my own interest to Jeff. I guess that's the most natural person here, but then of course, anything you'd like to add to the discussion. Okay, we should be using sampling weights, we got it. But having used the PISA and mostly the PIAAC data, where I think the problem is even more complicated, there's one additional issue on which I've always thought that weighting was particularly important, which is when you pull data from different countries together, because especially in PISA, the sampling frame for the different countries is it's not identical, but it's kind of similar. In PIAAC, it can be very different. So I was wondering what is the correct use of weights in that case when the population of interest is the union of different populations coming from different countries.
Right. So that's the key point, right? If you start off saying that your population of interest really consists of all of these countries, then the fact that there are essentially different sample sizes relative to population across the countries if you really want to make sure you're uncovering this kind of global effect, then you should wait for population across the different countries as well. I do have a sense, though, that that's going to make less of a difference in studies where you include time effects if you have a time dimension and country effects, because then this gets kind of back to this point where if in fact the weights depend on things you're conditioning on, then they're going to have less of an effect. Now, for them to have no effect, you would have to assume homogeneous effects across country and time, because whenever those coefficients differ, but you just kind of add country and time effects as additive effects, then you don't have the right model, right? You're getting this kind of linear projection that I talked about. And so the case for using the weights is basically that you would like to get kind of an average treatment effect, even if there's heterogeneity, and you do want to account for the fact that that sample that you're looking at across different countries is not a random sample from the entire set of countries for two reasons. The sampling within country, right, could be stratified, for example, and then the differences across the countries as well. Yeah.
Thank you. So, please.
Because of the participation rate, numbers of students can be highly different. For example, in PISA, Iceland, it's not a sample; it's a census.
Yeah.
So.
That's another issue, but
yeah.
So that does come back to this issue of trusting the sampling weights, right? I'm told, at least I've seen it in practice once in a project I was working on, that the survey statisticians looked at the resulting weights and said, no, these are too variable. It gives too much weight to these units, and so we're just going to truncate the weights, right? So, and of course, this is an art form, I guess. You want to kind of minimize the effect of a small number of units, but of course then you really are not recovering the whole population if you do that. Maybe Sabina's response to that. Please.
Yeah. So different sampling frames, different populations. So if there are really different underlying populations across countries, then I probably would not at all pool data because then what am I talking about, right? So, and then there are, you can do stratification in a very different way in all the countries, because that is always very country specific, as long as you can say you have one target population that holds, or the definition holds across all the countries, then you can have very different designs and still you can do, pooled analysis. Now, how to use the weights here, I would always, first of all, use the weights. That's for sure, because otherwise you will get unbiased biased results.
So I took the question to mean that would you have your weights account for the differences across country as opposed to just stratification within a country? At least that's what
well, differences across countries, I mean, as long as I'm doing pooled analysis, then my question, I would guess, is something like, do Asian students, for example, better than students from Europe? Let's put this question. So in this case, I would try to account for the population size, and because Singapore is very small, for example, or Hong Kong is very small, then the weight of these populations in such a question should be, reflecting the true population size. However, there are many, if you look at the reports and you have different types of averages, like, for example, there is always an OECD average, and to this average, the countries all contribute in the same. So the weights are adding up to the very same number once you put them in. It's called Senate weights, I think. So, and that's a purely political decision that has been made to say, okay, we have different countries, they should all contribute the same to the overall average. But here, there's no right or wrong, but the research question must drive the decision on whether you would use these Senate weights, and every country contributes the same, whether it's a very small country or a very big one, like Russian Federation, or are you aiming for answering another type of research question where you say, I don't know, I'm looking for, you know, the poorest quartile of, I don't know, students across the world that participate in PISA, something like that. Then you really want to have using the weights that really reflect the true population size.
That's all I was saying. By the way, there's an analogy here. In differences studies, like in the United States, right? You take 2 states before and after. If there's some sort of stratified sampling within each state, those weights, I think, tend to be used. I don't think I know of any cases where people wait for the fact that the relative sample sizes across the different states are different. And so in that case, people don't actually do a weighting to reflect the different population sizes across the states. That may not be the right thing to do, but that is kind of an analogy, right, where the weightings is not adjusted to reflect different population sizes.
Thank you very much. We're approaching the end. I don't know if there's any other pressing issue that any of you would like to bring on the table. Otherwise, Marco is ready for the final.
Yeah, thanks everyone. Thanks to the speakers and the discussants. Just to say that we will post the materials from the seminar online. We will get in touch with all of you, informing when the materials will be put online. And that's it. I hope you enjoyed this day. So one of the objectives was to bring people together and breaking these academic silos and having people from different disciplines and branches getting to know each other and talking together. I think we achieved that goal. And that's it. Let's keep in touch and have a very good weekend or trip back, whatever your plans are. Thanks.